Now what Spark is doing, let's suppose, okay, and so why that Python program will take time? Because it will running on the single computer, on the single processing, on the single CPU. It will try to add all the number and then it will give you. So what Spark do is do the parallel processing. So wherever most of the places you do that, Spark do the parallel processing and in memory. So about the in memory we'll talk later. Let's just first come to the parallel processing. So for the parallel processing, what Spark do? Let's suppose you give Spark that some of the number from 1 billion of number, okay, 1 to 10 to the power 9. So what it will do? Do the it will divide the task. Okay, it depends on your configuration and all that we will see. But what it will do? It will divide that task into the hundred. So what it will do? 1 lakh. Just one processor will do. Okay, 1 lakh, one two other processor will do. So what it will do? It will divide all the things into the, let's suppose, 100 part. So once you were doing on the one machine, it was taking, let's suppose, it was taking 10 minutes. Okay, just for example. So now it divided the task into 100 minutes. So all will do the sum parallelly of its part. Okay, and until once all the sum is completed, then we have just 100 sum left because we have 100 processing. Let's just go with the 1 to 1000 only. Okay, it will be easy to understand. Let's suppose our computer was doing the sum of 1 to 1000 and it added and those that calculation in, let's just take 10 minutes. Okay, it won't take 10 minutes, just it will take seconds. But let's just assume that our machine did it in the 10 minutes. Okay, so now if I ask Spark to sum this number 1 to 1000, what it will do? It will create 10 tasks. 1 to 100 one task, means it will create 10 parallel task it will execute. And how this parallel task will execute? One task will be from 1 to 100, other will be 100 1 to 200, 200. Next will be 200 1 to 300. Similarly, last will be 900 to 901 to 1000. So it will do all the parallel task. So let's suppose one processor, okay, just added 1 to 1000, other added 100 to 200. Similarly, all will do the parallel task. So each will take one minute. Okay, and in the next minute we will add all the tens. Let's suppose one give you 1000. I'm just giving you a random number. I'm not sure what will be the it will be added. Let's suppose that first task you first task give you the output of 10,000. Second will give you 20,000. Third will give you uh it won't give you 10,000, sorry. Let's suppose first will give you around 2000. Okay, second will give you something like that. Then what you have to do at the end, you have to just add the 10 task. Okay, so in that way you will get the output in just 1 minute. When you were running in the you were writing in one Python programming, that time you were getting result in 10 minutes, but when you do the parallel processing you are getting result in 1 minute. Okay, so that's how it do the parallel processing and reduce the time. Okay,
Got it. Yeah.
so that's the core, and also about the in memory we'll see that what is the in memory and how it is faster. So before actually before this Spark, things were big data, things were we were doing on the Hadoop. Okay, we were not going in deep of the Hadoop, but let's just understand what it was. So before Spark, we were doing all the processing things on the MapReduce on the Hadoop. And Hadoop was using the MapReduce. There are two phases. One is map and one is reduce. In the mapping, it was doing the mapping of the key, and in the reduce side, it was doing the calculation. Okay, and Spark is doing 100 times faster performance. If you compare it with the MapReduce, it will give you the 100 times faster performance because of the in memory. See, we have, if you do anything in the in memory, right? We have RAM, right? So if you do all the calculations and all are happening in the memory. So if you do in that memory, it will be very faster. So how MapReduce was working? It was using the disk also. Okay, not only the memory, it was using disk also for the calculations, keeping okay, that is a different we have to understand that, but let's just understand. So Spark is doing all the calculation in memory, but MapReduce was doing the calculation on the disk as well as in memory. Okay, that's why it was taking time. But as Spark is doing everything into the in memory, that's why it is 1,000 times faster. Okay,
Okay.
so then one interview question may arises that what is the why a map reduce or the Spark is faster than map reduce. So the answer will be because Spark is doing everything into the in memory. Okay, so one question arises that what is the why Spark is faster than the map reduce. This comparison happened because before Spark we were using the map reduce. Okay, so now what are the libraries Spark provide? So these are the Spark core. We will read about all those, all the three libraries: Spark core, Spark SQL, Spark streaming, machine learning library, and graphics. We don't. These are for the machine learning. Okay, so we are not going these things because data engineers mostly use only these three things: Spark core, Spark SQL, and Spark streaming. Once you well versed with the data engineering thing, maybe after that, if you want, you can switch to the machine learning also.
Okay.
Okay, so these three things will run. Okay, I told you, right? See here, it is mentioned in the second point. It provide up to 1,000 times faster performance for few application with in-memory primitives as compared to two-stage disk-based MapReduce paradigm of Hadoop. So actually, in the MapReduce, it was using disk as well as memory also. Okay, it was doing the calculation in the memory and then keeping the that output on the disk. So it was using disk as well as memory, but Spark do everything into the memory. So that's why it is more faster or 100 times faster than MapReduce. You can read more about it because that is an interview question. Okay.
Sure.
Yeah. So these are the three component. Will Spark streaming is used for the real time. It is not the exact real time, but near real time. We'll learn about what is the near real time and the real time. So in the Spark streaming, we are using the streaming. Like let's suppose you are clicking something here, okay, or some of the sensor data you are keep getting. So now you have to process that. So for that, we let's suppose you are so you are doing okay in the e-commerce website. So how once you search any product, right, they will start suggesting you some other products similar to that. So that can be also one of the use case of the Spark streaming. Like whenever you search any product, they will see that okay, you are searching for the shoes. Then that will be I'm just giving you one of the use case. It can, maybe the other companies can be using in other use cases, but I'm giving you one use case of Spark streaming. So let's suppose you search for shoe. Okay, then maybe in that data will be sent through the Kafka, through the Spark streaming. It will process you, and once you understand that okay, you are searching for shoes, it will start suggesting you some of the shoes. Okay, so that thing should be done in the real time. Okay, as soon as you search shoe, then I have to suggest you the different kind of shoes and socks or anything related to the shoe. So that is the real time use case. Or maybe some of the sensor. Let's suppose that you have like in the some of the industries you have different sensors, right? So you are keep reading the sensors data, and if you see any anomaly in the data or anything, then you will understand that okay, this sensor is faulty. Maybe we need to look at it. So for those things also you need to do the real time processing. As soon as you get the data from the sensor, you have to process it and see are the sensors are doing good. Okay, that can be one of the use case. So okay, so Spark SQL is actually initially when Spark once Spark came, okay, in 2005 or 2000 something, then only it has only this RDD first library,
Okay.
basically distributed database. Okay, this we call it the Spark code because everything whatever we see those are based on the RDD only. So we'll read everything. I'm just giving you a small brief about everything. Then we'll in depth we'll learn these three libraries: Spark core or RDD, Spark SQL, and Spark Streaming. So Spark SQL actually it has many optimizations. Okay, once you write any query, then it will optimize it. We'll see the what are the optimization it is doing. So one of the most important Spark question is what are the optimization techniques available in Spark, and they will ask you what are the optimization techniques you know and you have applied. Okay.
Okay.
So that is a one of the, I would say, in most of the interview or interview, definitely you will be asked this question. What the Spark optimization? Because that is very important. Because once you do on the Spark code, okay, then you need to know how I can optimize the code or optimize the query or optimize the job so that the performance can be improved. Okay, maybe you are running some jobs and in jobs are taking some 1 hour to 2 hour to finish. Maybe there are some scope of improvisation in the code. Okay, and if you improve it, or maybe you do some of the technique what are the available in the Spark. Okay, if you use that, maybe your performance can improve and you can just finish that job in 30 minutes. Okay, so that's why it is very important to know what are the Spark optimization available, and you should use it also. And they will ask you that what are the Spark optimization you have used. So on the Spark SQL side, it is like it is kind of you. There is a two way we can write. One is data frame and one is SQL. You can just write the SQL and give the Spark. That also Spark can process. Okay, so Spark SQL is kind of, you can say that you have the tables in the Spark and you have to just write the normal SQL. Okay, for that you have a Spark SQL. There is data frame also, data frame way of writing the query. That also we will see. But let's suppose you want to get some data. There is the table in the Spark. So you just write, select a star from this table and give it to Spark. Spark will give you. So that is because of this Spark SQL library. Okay.
Okay.
And now a Spark code. So Spark core is the resilient distributed data sets. So the distributed, as I told you, right? We are distributing the task, right? Parallel processing means dividing the task. So here Spark core only do all those things. So there are other things also, like Spark is fault tolerant. Okay, those things also we'll see. With the fault tolerant, what I mean is, like, let's suppose, as I gave you example, right? Let's suppose you are running 10 tasks, like 1 to 100 and 101 to 200 something. Those tasks we are running 10 tasks currently. Suppose something happened to one task, like where 1 to 100 was running. Okay, so Spark automatically, when it see that okay, this task has this server where this task was running has some issue, will automatically start that task on other server. Okay, so that's why we call it as fault tolerant. Means if any fault happen, Spark will automatically take care of that. You don't have to look at it.
Okay.
That's why we call Spark as the fault tolerant. We'll see more about it. And also in memory fault tolerant and okay, let's just talk about replication factor. Okay, what is the replication and why we are doing the? Let's suppose you have created one table. Okay, you have one employee table. So whenever Spark actually replication is one of the fault tolerant way, I would say. Why we are doing that? Let's suppose you have one table, employee table. Okay, so what replication factor actually in Hadoop and Spark all are like three. We keep minimum as three replication factor. So the thing is, like, why we are replicating the data. So that we are replicating the data so that if something happened to the data, let's suppose I store the employee table in one of the server. If something happened, I have the data at other two servers. Okay, I can take and I can read the data from there and I can process it. Other thing is, like, if I have the server, if I have the data at 2 3 server, like whenever we are running the Spark job, we try to run the job near to the data. Okay, that also we'll see. Maybe you don't understand these things now, but once we go later, what it is and why it is important, those things will understand. So replication factor, you just understand for now that we keep the data at the two more places. Let's suppose if I have any table, the replication factor is 3, then I will have that same table at two more places. We'll see that why we are doing that, how the fault tolerant is helping and all those things. So if you can change the replication factor, let's suppose you make the replication factor as 5, then you will have the 4 more copies of the data. But generally we keep the 2 more, like 3, we definitely keep the replication factor. So yeah, this is about these three libraries which we'll be learning. Okay, so we will in the industry mostly we are writing our code or anything we are doing on the Spark SQL. Okay. RDD, there are different way of writing the RDD code. You should know that because in the interview, in the application, very less you will in the while working, very less you will writing any code on the RDD directly, but most of your code will be on the Spark SQL. But still in the interview, people can ask you that write these things on the RDD. So that's why you should know RDD also. But in while using, you will be only using the Spark SQL. We will know, we will see that why only Spark SQL, because there are many optimization which are available on the Spark SQL but not on the RDD. But one thing, under the hood, everything Spark SQL or Spark streaming or machine learning or graphics, anything, everything will be using the RDD. This is the core of Spark, a resilient distributed database.
Okay.
So as I told, this is the foundation and Spark code. This provide you distributed task dispatching. So we'll see about what is the scheduling, how Spark is doing that. Okay. When you submit any job, how it is scheduling, how it is deciding that on which server it has to run. Those things we'll see. So is there anything important? So these are the similar thing. Spark code is the core of the Spark core and RDD. This is the foundation of the Spark, and this is the as a component lying on the top of the Spark core, right? Everything Spark SQL, I just told you, right? All these things, Spark SQL, Spark streaming, everything will be on the top of a Spark core, which is RDD. It introduces schema RDD, which can be manipulated. These things we'll see. Support, as I told you, right? Spark SQL, it support SQL. You can write directly the SQL and you submit that, then Spark SQL will run it.
Okay.
With ODBC and JDBC, these are the drivers, okay, or servers. I will show you what all those things. Spark streaming, it leverages fast scheduling capacity of a Spark code, ingest data in small batches. This is the I told you, right? This is not the exact real time, but the real time. Why? Because it is doing the processing in the small batches. So you can give the time, like let's suppose you and give the time like whatever the data you got in last 5 seconds, you just process it. Okay. So that's why as it is processing in the small batches, so that's why we call it the near real time, not the real time. So that also you have to understand. That question may come, that interview question, that why you call Spark streaming as the near real time, not the real time.
Okay.
And the ML leave and this graphics, we'll don't see it, we'll not looking at it. But anyway, as it is telling about the machine learning, so you can use the Spark for run the machine learning job also, and for the graph processing also. So graph and all we are using like in the Facebook, like whenever you have like friends and whose friend has, you have one friend and maybe his friend is other friend. So these there we are using the graph and all when you have to do the relationships.
Okay.
Okay, so as I told you, right, Spark is the doing the in-memory processing, right? Okay, in column-centric database, we'll see while doing the processing what is the column-centric database. But just to give you uh, what it is, okay. So in the you have worked on any DB, right? Like you told DB where you are using.
Yes, yes. DB, yeah.
Which DB you are using under the hood?
MySQL.
Okay, in the MySQL, okay, that is the row row based data base. Okay, so what is the okay? Okay, I don't have the, I cannot write it. Okay, from next class I will write on the slides also, so that it will be easy for you to understand. I have not
Sure.
set up that pencil there. Okay, so I cannot write it. But in the okay, let me just give you one example. You have one employee table. Okay, so
Okay.
this in the employee table, you have employee ID, okay, and employee name and employee salary. Okay. So
Okay.
I ask you to give me the sum of the salary. Let's suppose you have five employee, okay, A, B, C, D, E, and if all the salaries, each employee has salary of 1,000 rupees. Okay. Now I ask you that what is the sum of the salary? So definitely the sum of salary is 500. So when you have to write the query on the SQL, you will write select sum of the salary from employee table. So how this is actually doing? Under the hood, it scan all the rows. It will go to the first row. It will see that okay, A is the employee name, then sorry, one is the employee ID, A is the employee name, and 1,000 is the salary. From there it picks the 1,000. Then again it will go to the second row, and then third row, then fourth row, then fifth row, and from each row it will get the salary and then sum it, and then it will give you. Okay. So here we are doing row, we are going row by row, right?
Yes.
So that's why we call it the row-based database. And now the columnar-based database. So in the columnar-based database, mostly we are using in the big data world. Why? Because in the big data world, mostly this is also one of the important question you should know. What is the why we are using a columnar-based database? Okay, and why not the row? What is the difference between there is like file some of the file format like Parquet, ORC. These are the columnar-based file format. So those things we'll see. But this also you write one interview question, the columnar based versus row based database. Okay. And which to when to use which one. So
Sure.
in the I gave you one example of MySQL, right, where we have five employee and thousand salary. So in that, as I told you, it search row by row and then sum the salary. But in the big data world, we mostly do the analytics thing. Like some of the things give me the because in the when you do the analytics, mostly you don't look at the one person or one thing. You will mostly look at the whole table. Like what are the sum of the whole employee? Okay, what are the sum of the employee in the finance team? In the analytics, you won't see one thing. You just look at the bunch of thing, like means bunch of things. With that I mean the whole data, okay, or some part of the data, not row by row. So that's why in the columnar base, let's suppose if you are using on the columnar based database, right? In that case, if you ask the sum of the salary, it won't scan row by row. It will just go to that column, salary column. It will give you the sum of all those things. So that's why it is faster when you have to do the analytics thing. That's why
Okay.
in the big data world, we are using columnar based data, DB, mostly. Okay. So here it is mentioned, right? In column centric database, information which are similar can be stored together. Uh, Yeah, information which are similar can be stored together. We are storing, right? In the salary, we have all the things are salary. So that is stored together. And whenever you have to get the sum, you don't have to scan row by row. You will just go to the column salary and will get the sum. That's why it is faster. We'll see those things also. I don't have those things that are not in their syllabus. If I miss about the row or the column based thing, just remind me, okay?
Sure, sure. Thank you.
Because that is one important thing which you should know, that why we are using that column centric DB.
Okay.
Okay, as I told you, right, the Spark is working in the in memory. Everything is happening in the in memory. So what is the benefit of using the in memory? In the current computer also, when you do any calculations, or okay, everything will happen in the in memory. Okay, because it is faster in the memory. So Spark do all the calculations on the in memory and it is faster. So what it do is like it load everything. Let's suppose you are giving the employee table, right? And you want to give the sum. So it will load the whole table into the in memory, and it will get the salary call table. Okay, it will get the employee table. It will divide into the task, and then it will process all into the in memory and give you the final result. So it will do everything into the in memory. Entire information loaded into memory, eliminate the need of index. Do you know about the index? What is the index? And you know, right?
Yes.
Yeah, good. Just because in the interview question they will ask you that how you will improve the performance of the DB, then index can be one of the thing. That good, you know that. Okay, you know star schema and snowflake schema.
Uh, Yeah, I have an idea. Yeah.
Yeah, just read about that, because that is
Sure.
one of the important thing. We are not covering those things, okay, because that again kind of the data engineering thing. But I'm
Sure.
giving you some of the topics which you should read about it. Okay. So read
Sure.
about star schema, fact table, dimension table, what are the,
Okay.
when to use, what is the difference, when to use a star schema, when to use snowflake schema, all those things. Okay. Normalizations also you should know.
Okay.
1F, 2NF, 3NF. Okay, what is when to normalize, why we are using normalization, all those things.
Okay.
Yeah. Okay, so next is the compression algorithm. So they are the compression algorithm. Why we are doing the compression? Okay, when we have actually in the Spark, we are running on the multiple clusters. Okay, let's suppose when I say multiple cluster, one cluster will have multiple, you can think servers, okay, or multiple computers, you can say. Right. So let's suppose your computer is one server, my computer is one server. If in one cluster you can say, let's suppose we two our computers are in one cluster, then we can say that one your computer is one server, my computer is one server. So similarly, uh, actually this Yahoo had 50,000 servers in its Hadoop cluster. Okay, so they have 50,000 computers running simultaneously. 50,000. Okay, so let's suppose that you have to run some of the jobs. Okay, and you need 10 server out of it. So maybe you need to transfer the data from one server to another server. Okay, for that we do the compress. There are multiple compress algorithm. We compress the data and send over the network. We serialize the data. We send over the network. On the other side, we deserialize it. Okay, serialization and deserialization also I would suggest you to write so that you can read about it. Serialization and deserialization of data and how we are sending the data over the network. Okay. Okay.
Okay.
Anyway, we are touching those things in the Spark, but you can read about it. Okay, so that's why we are doing the compression of the data and sending it into the over the network. Querying the data loaded into memory in is different from caching. Okay, one more thing. You know about caching, right? How we are doing the caching and all.
Yes, changing the data type.
No, no, no. Caching is like storing the data into the in memory.
Okay. Okay.
Okay, read about the cache because that is a very important thing. Okay, so
Okay.
in caching, what is happening? Let's suppose if you cache some data, it will be stored into the memory. When you try to fetch the actually you have to understand two things. Let's suppose you have computer, right? You have your one of let's suppose you have one file onto the disk. Okay, whenever you try to read it, means when I say disk means you have your hard disk in your computer, right? So whenever you store anything, that is stored onto the disk, and whenever you try to read that file, it first load into the memory. Okay, then only you can read it, and you can okay, yeah, then only you can read it. So whatever the you have things on the disk, first you need to load into the memory, then only you can do any calculation on top of it. Okay,
Okay.
so okay, we were here, right? So caching is, let's suppose you have some of the data, okay, and you want to frequently read it, okay. Let's suppose that is on the disk. So then, okay, one more thing, reading from disk is more time consuming than reading from memory. Okay, if you have to read anything from disk, let's suppose it is taking 1 second, then if it is stored on the memory, you will just need 1 microsecond to read about it. That may be not the perfect timing what I'm telling, but I'm just giving you one comparison. Let's suppose your something is stored on the disk, you have to read it, and the same thing is stored on the memory. So if you try to read it from disk, maybe it will take 1 second, but from the memory it will just take 1 microsecond or 1 millisecond. Okay, so that's the faster memory. If you have anything in the memory, it will be faster. So if you do anything on the caching, then it will store into the memory. So those things you read, because that is also one of the performance improvement thing. People will ask you what is the caching. Okay, so just think about it. But see, now what it is mentioned here, querying the data loaded into memory is different from caching. As I told you, right, caching is also storing into the memory. But here it is different from caching because we are loading all the data into the memory and reading. In the caching, we don't need all the data into the memory. We are just reading the data which we are frequently accessing, or we need performance improvement on it. But Spark load all the data and then do the what are the transformation or the action you do. Okay, I may be using the transformations uh, in the while during our sessions. So transformations, you know about transformations on the
Ye-
data?
Yes,
Yeah,
yes.
okay, good. You know about, right? So let's suppose you loaded some of the data, okay, and you do some of the transformation on top of it. When you are doing any transformation, those everything will happen into the in memory in the Spark. So that's why it is a faster. So it is different from caching because in the caching we just store some of the data. We don't do every processing and everything into the caching. Let's suppose in the okay, let's suppose you do it, you have that salary, right? We do talk about that some of the salary. So what you can do is like you can do is like you store the final salary, whatever you got, you store into the memory, okay, and whenever you need, you can fetch it from memory. That will be very faster. Either you can store it on the disk or into the memory, but if you store into the sum that salary sum onto the memory, it will be very fast to access. Okay, in memory tool. Okay, so there are in-memory tools can help analyze different size. Like whenever your tables and things are the in-memory, you can easily allow access it, and concurrent user, multiple people can use the same access the same data within the seconds. These are not the important. Okay, one more thing. Spark is flexible with multiple languages. You can use Spark with Java or Scala or Python or R. Anything you can use. Okay. I told you about the real time, right? There are two things: batch processing and the real time processing. So what is the batch processing? Real time processing, I gave you example of the sensors and e-commerce, right? Batch processing is like, let's suppose you gave me the employee table. Okay, an employee table has let's suppose millions of employees. And if I'm doing anything on top of that on one thing, okay, or batch means you understand, right? Let's suppose you have one batch of the tables, okay, like some 2 GB or 3 GB of data, and you are processing it. Then we call it as a batch. Let's suppose you have 100 GB of data and you are processing it, and maybe it will taking 2 to 3 minutes to process the data, depending on your Spark cluster or any. Okay, let's suppose you have big Spark cluster and you are just processing the 100 GB of data in 2 to 3 minutes. Then in that case, we call it the batch processing. In real time processing, mostly in the you will get the data of very in the MBs. Okay, your data will be in the MB and at most in the GB, not more than that. 1 GB or some 2 GB, something like that. That is the batch processing. Structured data analysis. We'll read about structured. You know about structured and unstructured data?
Yeah, some I have an idea.
Yeah. Okay. Good. So this is good for you just read about that as also structured and unstructured data.
Okay.
So Spark is good for structured data. Like let's suppose you have the CSV, JSON, XML data. Okay, if you have all those things, then Spark is very good. It will directly you can store into the Spark and as a table. Means once you load that JSON or XML file into the Spark, you just think it is like you once you load it is available for you in the table format. You can just write the query. Okay, so data analysis will be very easy. Yeah, very easy on the Spark because you have to just load the data and you have to write the SQL queries. Okay, ML Leap, this is like machine learning things. You can do the clustering recommendations and classifications. These are like cluster recommendation and classification type of things which we are doing the in the machine learning.
But
Recommendation, yeah, go ahead.
clustering is something. Cluster is some library or
No, it's not library. It's like kind of you can think as an algorithm. Clustering means you make the clusters of the similar group. Okay, and that we call as the cluster recommendation is like it is suggesting you, right? As I told you, how they are suggesting you the shoes and all. Let's suppose you search for Nike shoes. As per your search, they are recommending things. So they are using this algorithm recommendation.
Okay.
And on the actually those things, the suggestions are all are coming from machine learning only. They will do the run the machine learning algorithm and suggest you things there. And after that, classifications means let's suppose you have to classify the okay, one more thing. In the Gmail, okay, you see sometime Gmail suggests you that this is the spam email, right? Or send it in the spam folder. How they are doing? They are using this machine learning algorithm classification. It classify the mail as spam or non-spam. If Gmail find that this email is a spam, then automatically it transfer it to the spam folder. So they are also Gmail are using this classification algorithm to classify between good email and bad email, like spam or non-spam, not good or bad, but what is the spam or the non-spam email. Okay, so this is also an interesting thing. Once you learn or work on the data engineering for 1 or 2 years after switching your job, you may start learning about machine learning. Okay, because this is very good thing, and also in the future you need this machine learning. You should have the knowledge and experience on the machine learning also. Okay, Spark SQL, I told you, right? Okay, Tej Impala, these we are not reading. Okay, these are actually using on the Hadoop. So yeah, but interactive SQL analysis we can do using the Spark SQL on the Spark. Real-time streaming data analysis, I told you about this. Okay, speed, I told you, combination. See, actually, previously, currently now, many people were using the Hive and Spark. Currently, also they are using MapReduce. Don't see people are using it. Okay, but the still okay, about the installation and all, we'll see about it. In your laptop, I need to install. You are reading Spark, right? Spark. We will install Spark in the local setup. Okay, we are not seeing at the cluster and all because we cannot set up that cluster. But we'll see. I will install into your local. Okay, from there you can practice the things, and also you have IntelliJ, right?
Yeah, I should have it.
Yeah.
Or
Yeah, just maybe we will use the IntelliJ for the coding and all. Or there, you can do the coding means you can open the terminal and write there. That also will work.
I have PyCharm.
But PyCharm is for Python.
Yeah,
We
yeah, I got
in
it.
Scala, right?
Intelligent.
So we need IntelliJ.
Okay.
Okay. Okay. Let's just look at the Spark. Okay, and then we in the session with this. Okay, let's just look at its architecture. Then tomorrow we'll start with in going the deep dive, like what is the Spark context, what is driver, what is worker and executor. So how I'm doing is like I will give you some context on the Spark. Okay, then I will start Scala. Okay, and then parallelly we'll do the programming also there. Okay.
Sure.
So I thought that let's just start with a Spark. In the beginning, I thought we'll start with a Scala and then we'll move to Spark. But it's good that starting with a Spark will like by the time you will be doing Scala, that time you can go back and read about Spark, and also from your side also you can start learning or reading more about it so that you can have question you can ask me.
Sure. Thank you.
Okay. So in the Spark, as I told you, right, we have multiple servers, right? And so you can tell that server as the worker. This is the driver. You can say as is the master. Okay. There is a master slave architecture. Okay. Once you read, you will come up with this term master and slave architecture, or master or worker architecture. What is that? See, master or in the master and slave or the master and worker, worker is to run the job. And master is to schedule the job and looking at the that which job is completed. Okay, once the job is completed, master will come. The worker will complete the job and tell the master.
Sorry, sorry. Yeah, go on.
So worker will run the job and tell the master that I have completed this. Okay, so in that case, a driver, master will send. Let's suppose you run the some job. Okay, you will send. You will submit that job to the Spark driver, or let's say master. Master will divide that job. It will look at. It will look at the workers. Okay, let's suppose that these two worker are from previously working or running some jobs. Okay, then master will assign that job to the worker which is free. Okay. And then once the worker completes that job, it will send back to the master and master will return you the result. So this is the things happening. And in the worker, we have executors. We'll read more about it. What is the executors and what is the Spark context. But on the high level, driver is something which assign job and worker is something which execute the jobs or the task. And we have multiple executors which store the tables and all that we'll see.
Okay.
But yeah, our driver, we'll read more about it. Like we have further, what is the Spark driver, what is the executors, everything we have. Okay. There is one more thing, cluster manager. Okay, this is not in the syllabus, but I will, high level, I will tell you about the cluster manager. Okay, what it is doing because it is very important, and so that you can, it is not big thing. I will just explain you about the cluster manager. You can just read about more about it just on the
Sure.
YouTube or anywhere. Okay, it is on the cluster manager is like it is the name is saying right. It will manage the cluster. As I told you, right? We have Yahoo has 50,000 cluster, so you need one cluster manager to manage that cluster. If something fail, then who will manage that?
Okay.
Okay, so those things, if you don't see, actually, if you in our local, we will not be running any cluster manager. Spark driver only will act as a cluster manager. When you don't have cluster manager in your system, then Spark driver will automatically take care of that, act as a cluster manager. Once you install in your laptop, the on the your local, you will have just the Spark context and the worker nodes, and also you will have just one worker node, not multiple worker node. Yeah, so I think that's it. Tomorrow or the Monday we'll meet. Okay, in between you just I gave you high level. Weekend you may look at some of the Spark video, like what is the driver and worker. Then we'll go in more details about it.
Sure. The DSA you mentioned from Geek for Geek, right? So that should be specifically for Scala.
No, no, no. That is I'm telling. Okay, they have in the Python also. I think they have. Okay,
Okay.
because mostly they have the one course in the DSA for the Java. Okay, but not for the Python. Um, not for the Scala. Sorry, not for the Python. I've heard that it has of the Python also. Okay, so see. But if you take the Java, you don't know Java, right?
No, no, I'm not aware of Java. That's what
Uh, See, actually, those concepts are not related to any language, but still, as you don't know Java, so I would suggest look at the if it has Python or not, or some from other places. You just look at the data structure algorithm tutorial. Okay, if some tutor, you can just look at it. Okay, and just check with me that you found these things. Shall you read from here or not? Okay.
Sure, sure. I
You just Google that what is DSA and why it is important. Okay, what are the important thing in DSA? Then on the Monday we'll discuss. If you
sure,
find any issue or if you have any doubt, we can discuss, and then I will suggest you that you can take this.
sure. Yeah, sure, sure.
Okay, but I would suggest that is very important thing if you are aiming for any product base, because DSA is the first round will be DSA, and there you will they will be asking, means that will actually analyze or your programming capabilities and your thinking. Okay, let's suppose I give you, there are many programs like they will give, if you know, actually, if you know the DSA, you can write efficient program. Okay, that's it is important to learn the DSA.
Okay.
So I would suggest definitely you read that, because any interview, mostly 90% interview have one round as a DSA, or if not one separate round, then definitely during your Spark interview only they will ask you to write a program to do the reverse the string, get me the sum of the string, find the if given the array, find the number if present or not, something like that.
Sure. Okay.
Okay, Isma, we'll meet on Monday.
Yeah. Thank you so much. Yeah.
So how the course will be, we'll read more. I will take one or two more classes in the Spark, then we'll move to the Scala. And there's you have the syllabus with you, right? They have shared with you.
Yeah, they are shared with me.
So in the that Kafka also, the Kafka we will be using for once we go to the Spark streaming. First, we try to read about the RDD and the Spark SQL. Okay, and those two library or those two API. Once we read about it and we do the some of the practice, then we move to the Kafka and then we move to the Spark streaming.
Kafka is something.
For the Spark streaming. I mean,
Okay.
for the streaming, Kafka is actually for the streaming, real time processing. It can do. So
Okay.
what we do in the Kafka from the, as I told you, right, from the sensors and all, we can get the data. How you will get the data? From the sensors, we will send the data on the Kafka, and from the Kafka, we use the Spark streaming for the processing of those data. We'll know more about it. Why the intermediate Kafka is coming? Why not directly sending the Spark and all, Spark streaming and all? We'll see about that.